All right, peeps, let's have a quick look at the answer to this question. All right, so in this particular question, because we know that we need the same base everywhere, we're going to write every one of these numbers as a product of their prime factors. So over here, we're going to get 2 to the power of 4 multiplied by 4 can be written as 2 squared, but remember that 4 was also to the exponent of x plus 3 is equal to, and on the side I've got 8, which is 8 2 cubed. That's to the power of x minus 2. So what we need to do next now is we need to multiply in. We need to distribute in those numbers over there. So what we're going to get over here is 2 to the power of 4 multiplied by 2 to the power of 2x plus 6. And C has given me a final answer. Let's see if your answer is correct. And then on this side, I'm going to get 2 to the power of 3x minus 6. Okay, now on this side, I've got like bases being multiplied. So I'm going to keep the base and I'm going to add my exponents. So I'm then going to get 2 to the power of 2x plus 6 plus 4 will give us 2x plus 10 is equal to 2 to the power of 3x minus 6. And now that I have the same base on both sides, I can drop my bases and make my exponents equal to each other. Hello, Mandisa. Okay, I'm then going to get 2x plus 10 is equal to 3x minus 6. Okay, and then from here, we can just solve for x. I'm going to take the 3x over to that side. I'm going to bring 10 over to that side. So we're going to get 2x minus 3x is equal to negative 6 minus 10. Okay, 2x minus 3x will give me negative x is equal to negative 6 minus 10 will give me negative 16. Therefore, I must divide both sides by negative 1. Divide by negative 1. Therefore, x is equal to 16. Sia, what did you do different to me that you got the answer that you got? Are we seeing where we didn't quite get it? I hope we are seeing where the mistake was there. I'm going to assume when we brought that plus 10 over, we left it as plus 10, right? And negative 6 plus 10 is equal to negative 4 or positive 4. So you would have had negative x is equal to positive 4. Am I correct? Was it this step over here? That step, yeah? Yeah, I figured. Yeah, I figured. But you know what? You were on the right track. I'm glad everything else you did was correct. So you're going to get all your method marks, and then you were going to lose 1 mark for the final answer, which is not bad. You would get 3 out of the 4 marks here. So well done to you. Good work. All right. Okay, guys, welcome to the last episode. Oh, I feel like I'm a YouTube star. How? We're going to be continuing with exponential equations, but this time we're going to mix it up a little bit because the exponential equations we learned about weren't just about multiplying on each side. We also learned about adding and subtracting exponential equations. Now, I want us to... Okay, let's start by answering this one that I have on the screen here. Okay, this is not question number 4. This is 4 times 25 to the power of x plus 3. All right. Try this question. Let me know. Just give me a yes or a no in the chat. Are you okay with answering this question on your own? Are we not? Tell me what we're thinking with this question. I think we did it in the last lesson as well. But I just want to check. Are we okay with answering this question, or would you like my help with it?
Can we try first?
Yeah, absolutely. Of course you can.
The Lord.
Okay. Let me know how it's going, peeps. Okay. I'll give you guys a hint. Remember, we want the thing with x on its own. So first thing we're going to do is we're going to get rid of this 4. And this 4 is multiplied to 25. So in order to do that, if it's multiplied to the 25 and we want to get rid of the 4, think about what you'd have to do there. I heard that. Say that again.
You must divide.
Yes, absolutely. We must divide both sides by 4. And that will give us an idea of where we need to go. I'm going to give you guys 1 more minute. All right, that's time. Let's have a look at this question, and I'm going to put the next one up on the screen as well as we go. Okay, so I know that I'm going to divide both sides by 4. I'm going to divide this side by 4, and I'm going to divide this side by 4. Those two will cancel. And on this side, we'll have 25 to the power of x plus 3 is equal to 4 divided by 4 is going to give us 1. Now, we said that if we want to make this base on this side look like that base, what must we make this to the power of in order for this equation to make sense? Anybody got an idea? Something to the power of what? I know that I want both my bases to be 25. So I want 1 to be written as 25 to the power of?
0.
Yes, absolutely. 25 to the power of 0. Good. And now that I have the same base on both sides, I can drop those. And I now have x plus 3 is equal to 0. Therefore, x is equal to -3. All right. And that's the answer we're looking for in this one. I want you guys to have a look at the next one that we have. This one over here. Just because this is a decimal, it shouldn't scare us, because we know that 0,5 can also be written as a fraction, yes? How can we write 0,5?
As 1 over 2.
Absolutely, as 1 over 2 or a half. Yes, absolutely. So we can change this to a half to the power of x minus 1 is equal to a quarter to the power of x. And then we can do that thing that Kat told us about on Monday. Remember how if I have something that has a positive exponent on the side, if I flip it to the top, it then gets a negative exponent. All right, I'm going to give you guys 2 minutes to work this one out as well, and then we'll have a chat. All right. All right, peeps, let's have a quick chat about this one. If you're stuck, that's perfectly fine. If you're still busy, you can continue. Okay. All right, so what I'm going to do here is I'm going to take this 2 over here, and I know that it has a positive exponent 1, and I'm going to flip it to the top, and what's going to happen to that 1 is it's going to turn negative. So I'm going to have 2 to the power of -1 all to the power of x minus 1. And that is equal to, I know that I can take 4 and I can write it as 2 squared. And because it's a positive at the top here, when I take it to the, at the bottom, when I take it to the top, it's going to become 2 to the power of -2. So I'm going to have 2 to the -2 multiplied by x. All right, and then I see a bracket and an exponent, so we're going to multiply out. So I should get 2 to the power of -x plus 1 is equal to 2 to the power of, oh, it's an ugly 2. That's supposed to be a 2, -2. Okay, this becomes 2 to the power of -2x. And now that I have the same base on both sides, drop both my bases. So my sum should read -x plus 1 is equal to -2x. I'm just going to swap things around. I'm going to take -2x over to that side. I'm going to bring 1 over to the side. So I'm going to get -x plus 2x is equal to -1. -x plus 2x is just x. Therefore, x is equal to -1. Let me know in the chat if you got it right. Tell me if you struggled, if you're like, hey, ma'am, I didn't even know where to go. Also, let me know so I know how best to help you. All right? Let me know how that goes. All right, here's the next sum. I would like you guys to try this one. Okay, now this question is very, very tricky. I'm going to give you guys that. All right, so I'm going to give everybody 1 minute to try and solve it. And if we don't know what we're doing, just be like, hi, ma'am, come and help me. But there are 2 ways to actually solve for this sum. Okay. One of the ways I think is logically applicable, and I'm not sure if it's a mathematical way that we can actually solve for it. Okay, so just have a look at these questions and let me know what we think. Okay, in the meantime, also have a look at this one and see if you can strategize around how we're going to answer this question. All right. Do you mean the one up top, the one above? Okay, sure. All right, everybody else, look at the question down there, and then we're going to have a quick chat. Wiganyo and I are going to have a quick chat. Everybody have a look at that one, the one in purple. All right, so Wiganyo, let me start by doing this first. Before we get into the fact that the exponent turned negative. If I said to you that I have 3 to the power of -3, and I told you I wanted you to put this thing with a positive exponent. I don't want it to be to the power of -3. I wanted to have a negative exponent, a positive exponent. What we would do in this case is we would take this particular number, we would put it over 1, and then we would flip them, right? I would take the 1 to the top, and I would take the 3 to the -3 to the denominator, and then my answer would come out as 1 over 3 cubed. Am I making sense there? Are we okay with that idea? Yes? Okay. So let's say now I don't give you this part. Let's say I give you that part. And now I've got all of this to the power of x, right? And I want you to express this as one thing, right? Now I know how I got this part, right? This part was originally 3 to the power of -3. So when they give us this thing in the middle, when they give us 1 over something, we're going to do this rule, but we're going to do it in reverse. So because they've already given us with a positive exponent, what I'm going to do is I'm going to take this thing at the bottom, take it to the top. What's going to happen to that positive 3? If I now take it to the top, what's going to happen to the exponent? It's going to become it's going to become negative, correct? So what I actually have over here is 3 to the power of negative 3 all to the power of x. Okay, and that's what we're doing in this example that we've got over here. Okay, so if you look at it over here, let's start with 0,5. We said 0,5 can be written as a fraction. We can rewrite 0,5 as 1 over 2 because 0,5 is the same thing as a half, right? But that half is all to the power of x minus 1. All to the power of x minus 1. Now, I'm going to do the rule that we just incorporated, but I'm going to do it in reverse. I know that any number sitting on its own has an exponent of 1. So this 2 over here actually has an exponent of 1, right? So now if I take this and I flip it and I take it to the top, it's going to become 2 to the power of negative 1, right? Same with this side. And then we're going to go equals, I'm going to open brackets. I know that 1 over, I can rewrite 4 as 2 squared. 4 is 2 squared. All of this to the power of x. And then again, I'm also going to take this 2 to the power of 2, and I'm going to take it to the top, right? And now I know that this positive exponent that I have over here, when I take this to the top, is going to become negative. All right. Are we okay with that, Wikanyo? Just let me know if you're still with me. You can even give me a thumbs up. Yes, ma'am. Cool. How are we feeling with what ma'am is about to do? We good? Excellent. All right. So now I'm going to take that 2 to the top, and it's got a positive 1 exponent. So in my bracket, I now have 2 to the power of negative 1. But this bracket was already to the power of x minus 1. And that is equal to, if I take the 2 squared to the top, I'm then going to get 2 to the power of negative 2 all to the power of the x that was already there. And then whenever I see a bracket and an exponent, I must multiply my exponents. Same on the side, bracket and exponent, multiply my exponents. I must keep my base though. So I'm going to get 2 to the power of negative 1 times x will give us negative x. Negative 1 times negative 1 will give us positive 1. And that is equal to 2 to the power of negative 2 times x will give me negative 2x. Right. And now that I have the same base, I can drop my bases and solve for x. So I've now got negative x plus 1 equals negative 2x. The negative 2x, that part will go to that side. The 1 will go to the other side, and their signs will change. So I will then have negative x. Negative 2x comes over, becomes plus 2x is equal to negative 1 goes over, becomes negative 1. Right? Negative x plus 2x will just give us x, and therefore x is equal to minus 1. All right, if you were still a little confused on that question, are we all okay with how Teacher Coco's done this question? Wikanyo, how are we feeling? Are we okay with the explanation? Cool beans, excellent. All right, let's have a look at this question over here. Now, I know that when we're looking at this question, we're like, hi, ma'am, the math is not mathing over here. All right, but the easier thing for us to do in this case is first to write 8 as a product of its prime factors. Yes, Mandisa?
Ma'am, I was actually gonna ask if that's what we were supposed to do with all the numbers that can't be with the 8 and the 27.
Yes, absolutely. That's exactly, yeah. Okay, so you can tell me right now, Mandisa, what do I need to rewrite 8 as?
2 to the power of 3.
Good. 2 cubed times 3 to the power of x is equal to, on this side?
3 to the power of 3 cubed.
Good. Times 2 to the power of x. Now, just by looking at this, just by inspection, Mandisa, what would we think x is supposed to be equal to? If we just look at it, yes, x needs to equal 3. Now, this question seems like it's cut and dried because if we just look at it, we should be able to do that. But I'm not sure if that's allowed as a mathematical concept. If we can just be like, x is equal to 3 because, yeah. Okay, I'm not sure if they'll allow you to look at it and answer it by inspection. So let me show you guys what I think we should do in this particular question. I'm just going to rewrite it over here. 8 times 3 to the power of x is equal to 27 times 2 to the power of x. Now, what I'm going to do is, just like when we solve for linear equations, I want anything with an x on one side, and I want anything without an x on the other side. So that means I want this 2 to the power of x on this side, and I want this 8 on the other side, right? But now these two things are multiplied to each other. So the only way I can get rid of the 2 to the power of x is if I divide both sides by 2 to the power of x, right? So I know that those two will cancel. And then I can also divide both sides by 8 because I don't want 8 on this side. I don't want anything with a number on the side. So those two will cancel. So what I end up with is 3 to the power of x over 2 to the power of x. And this is equal to, now Mandisa just told us that 27 can be written as 3 cubed over 8, which can also be written as 2 cubed. Okay, now let's go to a quick sidebar. We're going to go to a quick sidebar. If I told you guys that I have 2 over 5 all to the power of x, we all agree that this is the same thing as, I can distribute to each of them. I can do this. I can go 2 to the power of x divided by 5 to the power of x. Yes? Does everybody agree with me? Can I do that? Are we all okay? Now,
Yes,
what I'm going to do, cool. Now, what I'm going to do in this sum is I'm going to do this rule, but in the opposite direction. So where I have 2 to the power of x divided by 5 to the power of x, I'm going to take out the common factor x, right? So over here, I've got 3 to the power of x divided by 2 to the power of x. So I'm going to rewrite this as 3 over 2 all to the power of x is equal to, now on this side, I can also do the same because both of these things are to the power of 3. So I'm going to take 3 out as a common factor. It's almost like we're factorizing exponents. I'm then going to have 3 over 2 all to the power of 3. And then I have like bases. Do we see that I have like bases? So I can then just cancel. Therefore, x is equal to 3. Mind blown. Mind blown. How about that? Okay. Mathematically, I think this is how we're supposed to do it. I think this is maths and this is inspection. I'm not sure which one our teachers will allow us to do in either of these, but I'm thinking let's do the maths one just so that we can get all our marks. I know, Amanda, I know. I know. All right, okay. Let's talk a little bit about this next question that we've got over here. All right, in fact, we're going to talk about both of these questions that we have over here. Now, let me ask you guys again. I'm going to give you another example that we may have done in a previous question. If I said I've got exponents and I've got 2 to the power of x plus 2 to the power of x plus 1 over 2 to the power of x, how would we solve for this question, guys? Because I have a plus in the middle, what would I have to do on the top?
Factorize.
Absolutely, I would have to factorize. I'd have to split and factorize. I would split and then factorize, right? Split and factorize. Okay, so that's what we're going to do. We're going to go 2 to the power of x plus 2 to the power of x times 2 to the power of 1. Remember, that's how we split over 2 to the power of x. And then at the top, we can take out 2 to the power of x as a common factor. And we were going to have 1 plus 2. left on the top. 1 plus 2 to the power of 1 over 2 to the power of x. And only then can we cancel. All right. So in this particular question, now that we see a plus in the middle, we know that we must factorize. But before we can even factorize, what do we need in order to compare like bases? Now I've given away the answer. If we want to compare exponents, what do we need?
You need to
Like
have
bases.
like these.
Ah, that's such a cheat. I gave you the answer. I gave you the answer. Yes, we need like bases. All right, so we need to change 9 so that we have the same base. And we also need to write 36 as a product of its prime factors. All right, we can do this one together. So I'm then going to get over here 3 to the power of 2, because that's 9, all of that to the power of x, plus 3 to the power of 2x times 3 to the power of 1 is equal to, somebody put 36 into a calculator for me, shift fact, and tell me what 36 will give us.
2 squared times 3 squared.
Beautifully said, Kat, well done. 2 squared times 3 squared. All right. Excellent stuff. All right. So I'm going to rewrite this properly. I see a bracket and an exponent. I'm just going to multiply in. So I'm going to get 3 to the power of 2x plus 3 to the power of 2x times 3 to the power of 1 is equal to 2 squared times 3 squared. Right. Now on this side, we can factorize. What are we going to factorize? What kind of factorization are we looking at?
Highest common factor.
Absolutely. What is our highest common factor?
3 to the power
3
of
to
2x.
That's it. Absolutely. So we're going to go 3 to the power of 2x. If I take 3 to the power of 2x, what do I have left?
1.
1
1 plus
plus.
to the
To the power of 1.
1.
Good. 3 to the power of 1 is equal to 2 squared times 3 to the power of 2. What is 3 plus 1 plus 3 to the power of 1 would give us? How much in this bracket?
4.
4. We would get 4, right? Inside the bracket over here, 1 plus 3, that would give us 4. So I would then have, I'm just going to continue over here, 3 to the power of 2x multiplied by 4, I can even put that in brackets if we'd like, is equal to 2 squared times 3 to the power of 2. Now, I know that that's the thing I want. How do I get rid of this 4?
You divide on both sides.
We divide on both sides. Good. I'm going to divide the side by 4, and I'm going to divide the side by 4. I know that 2 squared is the same as 4. So 4 divided by 4, those two things will cancel. So my final answer is actually 3 to the power of 2x is equal to 3 to the power of 2. And now that I have like bases, I can just drop my bases and solve for my exponents. 2x is equal to 2. Therefore, x is equal to 1. All right. And that's the final answer. How did we feel about that question? Okay.
So, ma'am,
Where?
so like I also got the same answer, but like I used a different method.
Okay. You're going to have to explain your method to me, Kat, because it has to be a mathematical method.
Ma'am. I think it is though, but
Okay, tell me. Tell me what you did.
Every step from the first one to the third one, I did it correctly.
Okay.
So then when I came to this one, I forgot what the brackets mean multiplication, and I said plus, right? So after that, yeah, I actually made 4 an exponential number. So I turned it into 2 squared. So After that, then I took 3 to the power of 2x, made it equals to 3 to the power of 2, which gave me x equals to 1.
Absolutely, you can. Absolutely. I just skipped a step, my darling, because I was being lazy. But your way is absolutely 100% correct. Okay.
Oh, okay.
There's
Yeah.
nothing wrong with your way. I'm the one who skipped steps because I was being lazy. Okay. I want to give you guys another one to try. Here's another one. All right. 2 to the power of 2x plus 3 plus 4 to the power of x is equal to is equal to 36. No, not 36, 72. 72. I just need to make sure my maths is gonna check out here. Yeah. Is equal to 36. Let's leave it right there. Is equal to 32. Yeah. All right, try that one out and tell me what you get as an answer, guys. I'll give you guys 3 minutes. Okay, remember again, we need like bases everywhere and we must split and factorize. Okay, tell me how we do. One more minute, guys. All right, peeps, let's have a look at the answer. Okay, check yourself, check your answer with mine as we go. All right, first thing I'm going to note is that I don't have like bases everywhere, so I'm going to change 4 to the x, and I'm also going to change 32. All right, so I know over here I'm going to get 2 to the power of 2x. I'm already going to split it. So I'll get 2 to the power of 2x times 2 to the power of 3 plus 4 is going to change to 2 squared all to the power of x is equal to 2 to the power of 5. Is everybody okay with me just taking this 2 to the power of 2 to the power of x? Is it okay if I just rewrite it as 2 to the power of x of 2x? Is everybody okay with that? Can I do that already? Yeah? I don't think it would be a problem. We all know how we got there, yes? All right, so I'm going to then factor out 2 to the power of 2x over here. So I'm going to get 2 to the power of 2x, open brackets, and then I'm going to get 2 to the power of 3 plus 1. Guys, do not forget that this over here is actually a 1. Okay. And I kind of see where the problem is going to be. My sum is not going to work out the way that I thought it would. I was right with the 36. I should have left it as 36. My apologies, guys. Okay, it's not going to work out if I write 32. I should have left it as 36. Excuse me. So if I leave it as 36, I'm going to get 2 squared times 3 squared, which makes life a lot easier over here. All right, is equal to 2 squared times 3 squared. Okay, then on the inside here, I've got 2 cubed plus 1. That will give us 8 plus 1, which is 9. So I'm just going to continue over here. I'm going to get 2 to the power of 2x, open bracket, 9 is equal to 2 squared times 3 squared. Now, again, I know that I want the thing with the x, so I can divide both sides by 9 and divide by 9. I know that 3 squared is 9. It's like Kat said, so these 2 will cancel, and these 2 will cancel. And that means that 2 to the power of 2x is equal to 2 squared. Therefore, those 2 will cancel. 2x is equal to 2. Therefore, x is equal to 1. All right. Give me a thumbs up. How are we feeling about these kinds of questions? Okay. Okay, I'm getting radio silence today. I'm going to assume it's because everybody's tired because it's the last day of the term and everybody's on holiday from tomorrow on. Lucky for you guys, I'm not on holiday. Our school doesn't have public holidays, so I'm still going to work tomorrow. All right, which isn't fun. I don't like it, but it's fine. All right, let's talk a little bit about rational exponents before we run out of time here. All right, so rational exponents really don't do anything different to what normal exponents do. The only difference is that rational exponents involve rational numbers. Okay. Now, we did say that rational numbers are numbers that can be written as a fraction, as something over something. So what this is actually telling us is that our exponent is going to be a fraction. That's what it's telling us. All right, so let's take this question over here. 27 to the power of 1/3. Now, I want you guys to note very carefully that when we write something like 1/3 over here, this is actually the same as the cube root. It's the same as the cube root of whatever's on the inside. That is the cube root of 27. Excuse me. All right. So if I have, let's say, for instance, 49 to the power of 1/2, that is exactly the same as the what root? What kind of root would I be looking for here?
The square root.
Absolutely, the square root of 49, right? And we can find the answers for both of these. The square root of 49 is 7, and the cube root of 27 is 3. Now, how we deal with rational exponents is going to be quite easy, right? First, we're going to take 27 and we're going to write it as a product of its prime, right? So we know that 27 can be written as 3 cubed all to the power of 1/3. Right, so I see a bracket and an exponent, so I'm going to take 3 multiplied by 1/3. 3 multiplied by 1/3 is just the same as 1. So 3 to the power of 1, which is 3. And we know this is true because we've just done the cube root of 27 and we found that the answer is indeed 3. Are we all okay with this idea? We good? All right, here's a couple of them for you guys to try. Let's try questions 1, 2, and 3. All right, take it away, guys. not really difficult questions at all. Maybe question 3 a little bit, but question 1 and 2 should be fine. And you can just let me know how you're doing in the chat. You can pop your favorite emoji. You can send me a DM with your answers, and we'll take it from there. Mandisa's done. Nicely, nicely done. I'm going to give everybody else 1 more minute, and then we'll get started. Ah, nice one, Buikanyo. That's all we want. Okay. So just work with it the way that you're thinking. Okay. Okay, remember that last bit that we're working on over there is like bases being multiplied. So remember, because brackets mean multiply. Okay, all right, let's have a look at these questions. The last one, okay, the first one is pretty easy. We know that we can rewrite 125 as 5 cubed to the power of 1 over 3. And again, a bracket and an exponent, I'm going to multiply those. That's going to give me 5 to the power of 3 multiplied by a third is 1. And that's nice and easy. Okay. Is equal to 64 can be rewritten as 2 to the power of 6 over 1 over 6. Okay. So if I multiply those two, I'm going to get 2 to the power of 1, which is nice and easy. Now, this one over here is a little bit more tricky, right? Because I need to do both things over here. I'm going to rewrite 16 as a product of its prime. So that's going to give me 2 to the power of 4 multiplied by a squared. All of this to the power of 1 over 4 times a to the power 1 over 2. All right. So 1 over 4 times 4, and then 1 over 4 times 2. So what I'm going to get here is 2 to the power of 1 over 4 times 4 is just going to give me 2 to the power of 1. A to the power of 1 over 4 times 2 will give me a half. But this is all multiplied with this a outside, a to the power of a half. Right, and that's going to give me 2, because I've just got a 2. Now over here, I've got like bases being multiplied. So I'm going to keep my base a, and I'm going to add my exponents. Half plus a half will give me a to the power of 1, or just a. All right, and that's the final answer we're looking for over here. How did we do, guys, out of 3? Okay? Okay, so it just takes a little bit of thinking outside the box, but...
So, ma'am,
yes.
the second one, I also done it differently.
Okay, explain, how did you do it?
Changing 16 into exponential number, which I changed 64 into its exponential
Okay,
number, which is
so
8 squared.
that's 2
So
squared.
after changing it into x squared, I actually took 2 and multiplied it, right? Then it gave me 8 1 over 3.
Yes, 8 to the power 1 over 3.
Then after that, I also changed 8 and turned it into its exponential number, which is 2 cubed. Then I multiplied, and it still gave me 2 over 1.
Yeah, 2 to the power of 1, which is, I mean, the exact same thing, but I'm sorry to tell you, my darling, I'm only going to give you 1 mark and 1 mark. Even if you go the long way around, this is actually a 1 mark question. It's not even a 2 mark question. It's a 1 mark question. You're going to get 1 mark for this.
It's the mark that counts.
Okay, I agree. I agree. Okay, it's the mark that counts. I'll give you that. All right. I'll give that one to you. So I'm not going to argue with you there. All right, let's try questions 4. Okay, and then we're going to do step it up number 1. Let's try number 4. I think number 4 works exactly the same way that number 3 worked. Okay, try that one and try number 1 of step it up, because this one is a little bit more tricky, but because there's more steps involved. But let's try them both and let's see how we do. Well done to those of you who managed to get the other ones. They weren't that difficult, I don't think. One more minute. All right, peeps, let's have a look at these answers. Okay, so in question 4 over here, we're going to do the exact same thing, guys. So we're going to take 27 and we're going to write it as 3 cubed, y to the power of 6, all to the power of 1 over 3, times y to the power of negative 1. So I know that this is y to the power of negative 1. So technically, I'm actually dividing by 1, y to the power of 1. So what I'm doing here is I'm flipping this and I'm putting it in my denominator rather than putting it over here. All right, so at the top here, I'm going to multiply in with each of those, and I should get 3 to the power of 3 multiplied by 1 over 3 is 1. Y to the power of 6 multiplied by 1 over 3 is 2 over y to the power of 1. I know my like bases are being divided, so I'm going to end up with 3y. That one shouldn't have been too hard, right? Nice and easy. All right, now over here at the bottom, I do see that I've got a bracket and an exponent up top here. So I'm going to do the exact same thing that we've just done up top. So again, I'm going to rewrite 36. Okay, if I take it the long way around, this time I'm actually going to take it the way that Kat did her first question. So I'm going to rewrite 36 as 6 squared rather. 6 squared x squared to the power of a half multiplied or over 3. And now this x to the power of negative 1 down here, I'm going to take that and bring that to the top so that it becomes positive. So I'm going to have multiplied by x to the power of 1 at the top. All right, and we're just going to do some quick maths. We're going to multiply that one with that one and that one with that one. So I'm going to end up with 6 to the power of 2 times a half is 1. X to the power of 2 times a half is 1 times x to the power of 1 over 3. And that makes my life a lot easier. 6 divided by 3 is 2, and x multiplied by x is x squared. Okay, and that's what we get for today. How did we feel about that, guys? Not too bad, hey? I think these are pretty okay. These ones are quite nice and things. So we don't really have to worry about getting the correct answers and the such in these questions.